Hello, my engineer friend. The previous time we met, we learned about the Mobileye system for detecting vehicles and pedestrians on the road and alerting the driver about potential crashes. We concluded that the main process is synchronous, as it comprises sub-processes occurring in a specific sequence. Now, let's model the first detail level of this system, SD1. We will start with modeling SD, the top level, and proceed with SD1. The scenario we will model is when cars get ever closer, causing decrease in the braking time needed to avoid collision. We've already determined that the system's main process is vehicle in front detecting and crash alerting. What is the purpose of the system? What is the benefit that the system provides? The system reduces the probability of the driver crashing into the vehicle in front. The main function of the system is to provide the car with the ability to detect vehicles in the front and alert the driver when the braking time is too short. The enabler of the main process is the Mobileye system, which is an instrument. The system is part of the car. Notice that the driver is not an agent of the system because he or she does not handle it. The driver is environmental relative to our system of interest. So let's change the driver's affiliation from systemic to environmental. Another environmental object in our system is the car. The system architects and engineers have no control over the car, but the system has to be installed in it and use information it provides. The vehicle in front is also environmental, and it is an instrument of the main process, as our system does not transform it, but without it, there would be nothing to detect. And finally, problem occurrence. What problem does this system solve? The answer is related to the system purpose described previously. The problem occurs when a car gets close to a vehicle in front of it and the car's driver is at state not aware of the approaching danger. Lack of timely alert increases the probability of crashing. Having modeled SD, let's dive down and model finer details of the system in SD1. Detection of the vehicle in the front starts at a relatively large distance when the braking time is 10 seconds, but at this point, no signal is given to the driver. When the calculated braking time is 2.5 seconds or less, the little round display installed in the car shows this time in green digits. When the braking time drops to 1.2 seconds or less, the system alerts the driver by changing the braking time to red and sounding a single beep. When the braking time is 0.7 seconds or less, the system provides alerting for a crash. The display screen shows a big red car and multiple frequent beeps are sounded. Having reviewed this sequence of processes, let's refine the main process using them. Since we are modeling a synchronous process, we will carry out a refinement operation called in-zooming. A new OPD, SD1, is created with the main process inflated in the middle. How should we add the sub-processes to SD1? We shall use the timeline OPM principle, according to which sub-processes within a synchronous process are arranged vertically by the order of occurrence. The first sub-process will be at the top, followed by the next in line, and so on, till the last two occur, which will be placed at the bottom of the inflated ellipse of the in-zoom process. The timeline principle is key to modeling every synchronous process, so we should remember and use it. Applying this principle, let's add the subprocesses inside the main process. These are parts of the main process that contain them. So there is an aggregation-participation relation here. However, instead of using the usual link with the black triangle, the relation is expressed by the containment of the participating subprocesses inside the aggregating process. We can see the OPD we constructed expressed in the following OPL sentences. Here comes Hopcat to give us a definition.
A synchronous process is a process whose subprocesses have a predefined, fixed order. The timeline OPM principle. The timeline within an in-zoomed process is directed by default from the top of the in-zoomed process ellipse to its bottom.
Thank you, Hopcat. Now we will check or add details of the structure, behavior, and function of the system like we did in SD. Let's start with the system's purpose. Can it be linked to a specific subprocess in SD1? Well, we can say that the last subprocess, crash alerting, is the one delivering the system's benefit. Indeed, this subprocess is connected to the object crash probability. What about the main function of the system? Is there a specific subprocess that is responsible for it? Yes. The first subprocess enables the detection of the vehicle in front of the car. Indeed, the object vehicle in front alerting ability in SD1 is connected to the first subprocess. In OPM, every process must be linked to at least one transformee. To comply, let's go process by process and add a transformee to each one. What object is transformed by the first subprocess, detecting? This subprocess transitions the state of vehicle in front representation from not detected to detected. Good. What about the second subprocess, informing? Here, we can also show a state transition, again of vehicle in front representation, but this time from detected to driver informed. What about the next subprocess, alerting? It changes vehicle in front representation from driver informed to driver warned, as braking time becomes even shorter. Finally, the last subprocess, crash alerting, changes vehicle in front representation from driver warned to crash alerting, when braking time is less than 0.7 seconds. See you soon!